I hope everyone took some 10 deep breaths during that time, or thought about some birds in your backyard, or little things that bring you joy every day. I'm really excited to now have our next panel with Brooke Roberts-Islam, the founder of Techstyler and a senior contributor on sustainability at Forbes. And again, Brooke is one of my favorite reporters in this industry, really because of her desire and determination in getting into the details. I think everyone's learned throughout this process, and hopefully if you've been in this industry more than a few minutes, you understand how complicated it is. It is not simple. And Brooke has really been determined in finding and understanding that complexity, and has done an amazing job in distilling it for all of us. So thank you so much, Brooke.
Thank you, Nicole, for that lovely introduction. It's great to be here. I'm really excited about this topic. It's one I dig into regularly, as you know, and we have a great lineup of panelists, so I can't wait to get into it.
Yes, so I will leave it to you to introduce the topic and the panel. So thank you so much. I'm really looking forward to this.
Thank you, Nicole. Thanks again. Okay, welcome everyone. It's great to be here. I'm very happy to be moderating this panel discussion today called Closing the Loop, Next Gen Materials and End of Life. This is a challenging topic, a challenging, very sort of dense topic, but fortunately today what we're going to be doing is firstly digging into some descriptions and some demystifying language around it to set the scene. And then we're going to be drawing on some experts who are working in this area every day. So I'd like to introduce the four panelists we have today. Luis Schuler from Paradise Textiles, Yuli Fuentes, who's a senior advisor at Closed Loop Partners. She's also an academic though at MIT, so she's straddling those two spaces. Charline Ducas from the Microfibre Consortium, and Teresa Krug from Circ. So I'm going to give each panelist a minute or two to really give us a bit of background as to their experience and what their companies are trying to achieve before we dig into the details and get into the discussion. So maybe you can kick us off, Luis.
Yeah, hi, I'm Luis Schuler, based in California, and work as head of innovation for Paradise Textiles. Paradise is the textile and innovation arm of Alpine Group, which is a vertical manufacturer that works with many sportswear, fashion, outdoor brands. And a lot of my work is actually focused around this specific topic, exploring new materials, what are the viable alternatives, finding out how to test them, and then not only just test them to make sure that there's viability for the brands we work with, but also how they can be implemented into the supply chain so that they're not only from a technical and durability perspective, but they're also commercially viable.
Super. Thanks, Luis. And Yuli.
Yeah, of course. So hello, everyone. Thank you for being in this panel. I know online is now the new way of communication. So my background is in technology. I was trained as a biochemist by training in college, neuroscience and economy back in MIT. So the whole understanding of circular economy to me, it's a viable model of economy for the world to keep building up in the way we are building. I live between the two worlds. As you say in the beginning, I work in MIT as a person who manages a portfolio of research in the new ideas evolving for the textile industry. And I also work with investors, understanding what are going to be the strategies for deployment of capital for circularity. So I've been adopted by the fashion industry in many ways. And with that love, I've been trying to be a force in understanding how science can keep us in the pathway of future.
Great. And also dealing with how the money flows to where it needs to go, which is clearly crucial. Charline.
Yeah. Hey, everyone. So my name is Charline, based in Brussels. And I'm here with the Microfibre Consortium, which is a nonprofit working on leading the industry to reducing microfiber release and protect the environment. My background is in materials, so I'm a textile engineer by training. I worked in material development and spent my career working across businesses and nonprofits actually around materials and sustainability within the textile industry. So I'll have a focus on fiber fragmentation today, but my experience is actually very much related to the other topics that will be discussed in the panel.
Great.
Thanks.
And, Teresa.
Thanks, Brooke. I'm Teresa Krug. I lead innovation for Circ, based in Virginia. We are a textile circularity company, and we take mixed polycotton waste and recover that back to PET and lyocell fiber for new garments. I'm very excited to be here. I have, before Circ, a 30-year career in pulp and paper packaging, which is an industry that has had its own journey in increasing fiber recovery and recycling. So have been excited to bring that knowledge and skill set to bear in the textile world.
Super. Well, we've got a great breadth, really, of operational knowledge here, as well as academic knowledge, and then on the investment side as well, what it takes to get the right money into the right places to commercialize these solutions. But before we get into the details, just to set the stage a little bit for our audience members so that they know exactly what we'll be covering in this discussion. The focus here is really to look at next-gen materials and end of life. So the scope is to understand what feedstocks are out there that we can draw upon that are not virgin and that can be used to make materials that are either equal to incumbents or higher performing. And so this adheres to MII's definition of next gen, which is high performance and environmentally preferable, as well as being animal free. And then when it comes to the circularity part of this discussion and end of life, really what we're talking about is materials that are recycled or recyclable, along with the environmental impacts like microfiber shedding and the consequences of those. So to set the scene a little more here, what we're really talking about with next gen materials is new ingredients. How can we make new materials from the ingredients that we have out there? And, you know, cellulose that you've alluded to, Teresa, is the most abundant polymer on Earth, and it's present in agricultural crops, in residues, and, you know, it's burnt to sort of clear the way for the next crops, but it could equally be used as the cellulose feedstock for lyocell. So what we're talking about here is reimagining the ingredients around us and understanding how they can plug in to technologies and then drop into the supply chain, which is what Lewis explained. You know, they can fit into infrastructure and become a part of the textile supply chains we have today. So getting into that a little more, what we need to sort of know about next gen materials is, how do they work? How viable are they? What do they cost? And then how circular can they possibly be? How far can they go to solve some of the problems that we face today? So to get into that discussion, I want to highlight just a couple of things first. You've presented with us a great example, Teresa, in the lead up to this panel, and that is your collaboration with Zara. So what you've done is take end-of-life textiles, combining cellulose and polymer textile waste, so cotton and polyester, separated them out. They've been spun and turned into new textiles and then dropped into new garments. So maybe you could start by talking us a little bit through the process, I guess, and your part in it, because you're creating new ingredients, and explain to us a little bit about that process of separating those two waste streams within the single textile, and then how you've worked with your supply chain partners to deliver it.
Absolutely. And, you know, one of the things that it couples with what you had said about new materials from additional feedstock is one of the things that Circ focuses on is over and over again being able to reuse and recycle the molecules that are already out there so that you do not need virgin sources. And so in this example, when we worked with Zara and their parent company, Inditex, which has been a fantastic supporter to Circ, is that we took the mixed polycotton waste. We were able to dissolve the polyester back to monomers, which were then repolymerized into new PET fiber. And the resulting cellulose was then transformed into a dissolving pulp for the lyocell process. The reason we focused on lyocell is it's an environmentally friendly chemistry and process. And so we were able to then take that back to our partners at Zara and work with their supply chain partners to turn those fibers into fabric, go through the dyeing process and into the designs that they envisioned for the capsule collection. One of the challenges that we faced in that is that we have a demo plant, which is very capable of providing sampling materials out to the industry, but is not at the level of scale. And Yuli did a great job talking about the investments that are really needed to transform this industry. That was one of our challenges. So we did have to work with supply chain partners for things like the polymerization and the actual fiber creation. And so the process as we see it as we scale up is that instead of in this launch, we did have to blend, we had to extend the material we had. So we weren't able to deliver a final garment that was 100% recycle, not because the technology isn't capable of that, it is, and we have made garments out of 100% recycle, but just to extend the amount of material available so that Zara could fulfill its vision in releasing a commercial scale collection. And so that's one of the next things that's a challenge for us, is making sure that we can scale this up, and the brand demand is tremendous. And we can't build the factories fast enough to meet that demand. So I guess that segues into what our challenges are. But that's really the process we used, and the partners that we've had, which have been such a tremendous asset to us in accelerating our journey.
And I think what you've described there, Teresa, highlights just how difficult this kind of work is, because you're a segment of a much larger operation, really. You're developing a new feedstock for spinners. You're developing their ingredient for them to create fibers or the filaments that then go into the textiles that are used in the product. So we shouldn't take for granted that the challenge is solving the technical problems. No, it's that and the operational problems and challenges that arise around it. So, and Lewis, I know that you're working intensively in this area, not just exploring the opportunities that are out there, but working out which ones can drop into the work you're doing at Paradise Textiles and how you can then use those in your products. So how do you work with the likes of a Circ, or how do you work sort of in this space?
Yeah, so I mean, really what we'll do is we'll initially start by getting the fiber, doing the testing, we'll spin into yarn, determine, whether it's somebody like Circ is a bit more progressed than maybe some of the other earlier stage innovators we work with. But we'll support from an R&D perspective, and, go back and forth. And like in this space of next gen materials, for example, there are a lot of companies that, maybe they have a biotech background and they've got something that they think is viable for textiles, but they don't understand the processing that happens at a later stage. And so we really support from an R&D perspective and saying, okay, so this is what we're going to do. We're going to take your fiber, put it through this processing, then it goes into fabric, dyeing, finishing, heat setting. And we work out some of those things early on to determine, where the potential obstacles could be. Somebody that's at a stage like Circ, what we would do is we would get the fiber, we'd spin into yarn, we'd make some collections, and then we'd work with the right brands that are a part of our ecosystem already, and find out, like Circ would be a great one. We're also working with Evernew, so companies that are in this space. What we're doing is going and looking at collections that are currently using wood pulp based lyocell, or even viscose or rayon, and we're saying this would be a nice, viable alternative. And then we would propose, let's take out current running fabrics. We'll develop them with this new fiber that's a better alternative and propose to them. And then, that's a good way to change current running fabrics where there's a great alternative in place. And then moving forward, any new developments, we'd focus on using those fibers.
And what sort of conditions do you need, though, internally to be able to run that kind of development? Because it's, in an industry that works on volumes with commodity fibers, it's not as simple as say, we're going to try something new and let's shut down our production to do a few experiments. So how do you set yourselves up to be able to develop like that?
Well, luckily for us, we're getting at the fiber stage rather than the pulp stage. So that's really kind of seems to be the big blockage in like pipeline development stuff, is getting from pulp to fiber. And, the limited amount of companies that have those capabilities, don't want to take their production lines off. Their pilot lines are full, running trials. So it's a bit easier from our perspective because we're just taking the fiber, and then that fiber can be spun into yarn the same way that you would use viscose or cotton or hemp. It's just another fiber type. And most of these new alternatives, they are lyocell. So they're going to be very comparable to what you've worked with. I mean, basically identical. We've even done stuff with nanolose, for example, which is a microbial cellulose. And it's got this 99% same chemical structure as a wood pulp based cellulose. So luckily in this space, when you're talking about man-made cellulosic fiber, they really are a drop-in solution, less obstacles working with those as say, compared to like a biosynthetic.
Right, where your parameters are quite different, the resin input is quite different, and a lot more optimization and expertise, I guess, is required.
Yeah, you're changing your extrusion temps and your draw ratio, and then you have, even once you get to that point and you have a yarn, then you have to learn how you're adjusting all of the post processing beyond that to account for the thermal stability of those fibers.
And Yuli, from your perspective, so we've touched very briefly here on one of the roadblocks there from pulp to fiber. What I've been hearing repeatedly through discussions at various summits is the knowledge gap, the expertise gap, the ability to apply new inputs, new variations on incumbent materials into infrastructure and optimize in such a way that commercialization is possible. Can you talk us through a little bit on the academic side, and I guess how you then lend that to the financial side to either de-risk or explain and facilitate funding?
Yeah, of course. I mean, listening to Louis, he's living it, right? So it's a language barrier, right? So you have to have a really rich language to understand all the segregation of the supply chain. So this idea that you will build materials that will quickly drop into the supply chain is kind of an intermediate step for what's going to happen in the future, right? So do you really delete all this industry and then start over? No, you can't. We have to kind of work with the machineries we have today. In order to really rethink and reimagine these materials, I think basically what we're talking here is also understand what is the value that we're creating with these new materials, right? So when I hear Teresa speaking about these new fibers, it's not only that you are kind of taking feedstock that is today considered waste, but you're also building a new filament that has better performance and other characteristics that are going to give companies different abilities to build products. And in that creation of value is when you start kind of building an economy of circularity that kind of makes sense why we need to do this. I'm dying to see what Charline says, but yeah, we need to think in kind of this material is going to produce this amount of microplastic and things like that. How do we deal with the system as a whole? So from the academic point of view is to reimagine the system from the input and output and the areas that we need to keep improving, because it's not one single bullet solution in a way that you think about the materials, in the way you think about the design and integration, in the way you think about the relationship with the consumer, because most of the time you don't have a relationship of you. Today we have a relationship of buying things, but we need to go back to a relationship of stewardship, right? We need to care. We also need to understand the metrics, right? So the academics has a huge role in understanding how we're going to measure this. And today we're measuring this by the kilos, CO2 equivalents, the biodiversity, and it's a whole mix of standards that people is trying to fight constantly. What is your LCA? Are you really reducing the impact? So it's too much for one person operation. So that builds a fundamental principle for this new industry, which is collaboration. We have to be able to collaborate across the supply chain. And when you start thinking about the financial model with collaboration, we're building a little bit of a shared economy of how we deal with the segregation of the supply chain, how the drop-ins of innovations are going there, how are you de-risking that with capital that is in the equity space. But then when you have the first pilot plant, you need to think in a different form of economical model, because you need to start thinking a different color of money. Equity is one color of money. Infrastructure, dev money is a different color of money, and they have different rules. And we don't have people dealing with all those rules at the same time. So it requires these hybrid thinkers that are going to be able to really make that creation of value viable as an economy for circularity.
I think the challenge here as well, though, is really we're talking about ingredients, aren't we? Because, Lewis, you were talking about dropping Circ's pulp into existing processes where you would otherwise use a virgin wood pulp, or, you know, what we're talking about is parts of a process. So I think it's very difficult as well to really understand the business case in some instances for switching out an ingredient. And then on top of that, of course, we have the dye stuffs, the auxiliaries, the processes that go alongside of it. And that's where the discussion moves from not just being about the business case and, like you said, the sort of circular economy collaboration, but what about the consequences beyond that? What about the pollution credentials? Because we can't take for granted that a next gen ingredient is better if the chemistry used is ultimately undoing some of that improvement. So, Charline, let's hear a little bit about that side of it, because we shouldn't oversimplify this and just think about it as a feedstock and a sort of raw material issue. Circularity and circularity of next-gen materials, alternative, outputs, is also linked to other factors. Could you talk us through some of those factors for microfibers and how that's assessed in terms of pollution and how that fits into the circularity picture?
Yeah, if we go back to circularity, it's more than closing the loop and reusing stuff. There is a big design element on separating the biological cycle and the technical cycle. And fiber fragmentation, microfiber shedding is just a result of not doing that and doing products for the technical cycle that end up in the biological cycle without any control, without any understanding, without any knowledge. And that breaks the intrinsic rule, rule I will call it, behind circularity, which is more than recycling and end of use solutions and so on. And I guess this is a very relatively new topic. It's been discovered in nature maybe 5 years ago. We are trying to understand what happens and how things happen and what are the influencing factors. What is driving fragmentation? We know it happens. We know it happens across the life cycle through production to use to end of use. But we don't exactly know what drives it, and we don't and even less what to do about it. Because until we understand where it's coming from, it's very hard to put in place a no regret strategy where we are sure that it's better than what we had before.
Can I just pause just for a moment there, Charline, because I know that Lewis has done work in this area, and I'd like to hear about what Paradise might be doing on this side, or Paradise's viewpoints on this problem and how it could be handled. And perhaps then we'll come back for a little bit more of the testing phase from you.
Yeah, so I mean, we are a signatory with the Microfibre Consortium. We're running the AATCC 212 test method in-house, and actually it's something I'm pretty excited about. We do have a full-time analyst that is only testing new materials. So, going through cataloging current materials, and, we're charting all of the metrics on there about, country of origin for fiber, yarn twists, dyeing, heat setting parameters, like anything that could have a play into contributing to a textile's propensity to shed fiber. So we're trying to gain insights, and that's something that we'll be working with the Microfibre Consortium, running their test method and sharing data, continuing to build that collective data. So we do that. What we do is we'll take existing materials and we'll start tearing them down and saying, okay, how could we recreate that same material without affecting the hand or the aesthetic, and have a lower shed version of that? And then, of course, any new material we develop, we're testing. So if it's something that's like an immediate red flag, we're going to the brand and saying, actually, like, are you sure you want to do this? Like, here's some viable alternatives to do so. Mm-hmm. So that's really from the design stage. And then from the manufacturing stage, I was just in Turkey on our first trip last month with a company called Matter from Bristol. Mm-hmm. And we're partnering with them on an industrial filtration device, and we'll be implementing that into our dye and washing facilities as a way to capture microfibers right off of the machine. Mm-hmm. Of course, machines currently have filtration, and there's the wastewater treatment, but that's the level of fibers, that those are capturing currently. They're not fine enough. The microns in the screens are not fine enough. So anyway, we're working on something to help, capture microfibers from a manufacturing stage. And so I think, there's so many paths of what needs to be done. And I think all of these paths need to be explored and implemented immediately, but we're really focusing on design of the textile, and then from the manufacturing stage, how we can capture as many fibers as possible.
Yeah. And so, Charline, on the testing side of things, just zeroing in on that at the moment, could you distinguish for us the difference between the AATCC TM212 and the TMC method fiber release tests, and just give any kind of general information on the trends you've observed there? This is something that's, I know, is important to our audience as well.
Yeah, so I'm not a testing specialist, but I will send you a link that explains the differences between the different test methods. AATCC is mostly used in the US. Mm-hmm. The Microfibre Consortium is a little bit more used in Europe. They are not 100% the same, but they're also not completely different. Mm-hmm. But we have a resource which I can drop in the chat.
Fabulous.
For people to read.
Yeah, that would be great.
Yeah.
And Teresa, from your perspective at Circ, I know that you're a step before this, but in terms of circularity and your approach to using, let's say, ingredients, non-virgin ingredients, including textiles, what's your breadth there? What's your input, your feedstock scope?
Yeah, so right now we are, because again, our scope in there is so much polycotton waste out there. Because again, if you're looking at mechanically recycling, cotton, 100% cotton, there are options for that. The same way with 100% PET. So we really are focusing on blended. because, we know that, if others can do a feedstock, we really are focusing on that sweet spot of we can take everything from 100% poly to 100% cotton, but the blends are where we're focusing now. We've done post-consumer, but right now, because our scale is smaller, we are focusing on post-industrial because there is plenty of dead stock, there's plenty of trim and cuttings, and so that has been our intake. And then to your point about additives is, we've got feedstock assessments so that we can confirm that we can, if something had, the dyes and additives that are used won't impact the process. Now, right now, we are not recovering those. So to Charlene's point, it's not just about what you can actually reuse into the new fiber. You have to make sure that everything is recovered responsibly, and then ideally won't become waste as we're developing the new materials. So that's the other thing that, it's great to hear Louis and folks that have input into the design of materials that are more user-friendly from the beginning on some of the dyes and additives and print techniques, because that's going to be really important to make sure that you get to the 100% and also don't have issues. I call them unintended consequences, but as you're trying to design new materials and you're trying to make sure that you then recapture and recycle, that you haven't made a problem worse because you're designing for one process, you change pieces of the additives, and now something has derailed. So we're also designing for a closed loop system so that we do reuse the water, we reuse, everything's environmentally friendly chemistry. All that has to be designed into the system. So that's the way we're thinking about upscaling for the first factories.
And how does that work in terms of your remit, Teresa? Because you're working with a lot of supply chain partners with embedded practices and with existing, dyestuffs and auxiliaries providers. And I keep coming back to this, I know, because it's sort of a part of a much bigger process, but this is the reality that we face, is that we do not control everything, and that's why this is such a complicated problem to solve. So how do you then work with your supply chain partners and understand those processes in order to make sure that microfiber shedding down the line of potentially toxic dyestuffs doesn't happen?
Yeah, and you said it in terms of the work with, because we are not the experts in every potential downstream process. So we have really tried to get educated on where we have degrees of freedom, and ultimately there's two sides to this. We would love to see everything as cost effectively renewable and recyclable and closed loop as we can, as fast as we can. But you have to start with where are we going to be a drop in? Who are we working with that has the same values and the same commitment to using sustainable materials, and start thin slicing where you start and how you roll out. And so that's where the brand commitment has been so important for us, is because if you look at some of the brands that have those sustainable commitments for getting to a certain sustainability profile by 2025 or 2030, those are the brands that, if you look at as not only our solution, but other solutions out there, if you look at all of the potential factories that could come online, brands are going to have to really commit and start working with folks, not just Circ, but these kinds of solutions, or they won't meet those sustainability commitments. So offtake agreements and then working toward design for recyclability as early as possible is very important, not just for what you're talking about, so you actually design something that's not going to cause harm in another way other than just recycling, but also, again, back to something Yuli said, but so that you can get funding for these larger scalable solutions.
An interesting point that we should probably touch upon now is this notion of end of life, because it's a facet of what we're covering in this panel discussion. But as you well noted, your feedstock at the moment is post-industrial, not post-consumer. And that highlights one of the huge challenges facing next-gen materials from textiles, and that's the fact that they're not adequately collected and sorted right now and separated into appropriate feedstocks for new technologies. So let's dig into that a little bit. Maybe, Yuli, you could weigh in on this front, because I know that you're working on the investment side, and I know that closed loop partners have been looking at collecting and sorting technologies and vetting them. Could you maybe talk us through that very first initial step and some of the sentiment there, so that we can better understand why end-of-life garments aren't the feedstock for these next-gen materials yet?
Yeah, I think one of the things that when we think why something will be investable, we have to think who is the beneficiary. So at some point, if we think in the long term, people, customers, humans, we have to realize that we have value in our closet, right? So that's one of the mind shifts that needs to happen, right? So all this I call this the marathon. So all what the companies are doing today with this dead stock is kind of the training of the real marathon, and how they're kind of optimizing the chemistry, and in this case, the temperatures of the machines, molecular or mechanical. But the truth that has to happen is that the customer has to realize that they have value in their closet. That's step one for the economical dream to happen. The second step is the principle of what used to be for the waste industry, the three-stool model, right? You need to have capabilities to collect, you need to have capabilities to sort, but you also have to identify secondary markets that are going to bring value to the waste industry, right? So when we see companies like Circ and others building these new fibers, increasing the value in itself to the fiber, it's kind of giving possibilities, because today you might pay X amount of dollars for the textiles. In the future, it might go prime, and then all of these components from brands saying, yes, I'm going to pay you X, enable to de-risk the operation that somebody will put X amount of dollars for a new plant for these facilities to exist in different places in the world.
Lewis, talk to us about value, because I know from many previous conversations that the value of the textile itself within the whole value of the product is actually relatively low. There's not a lot of value attribution, let's say, just in hard, monetary terms to the textile itself. So how does the business case be made for collecting all of this waste expensively and automating it for a material that is only a tiny part of the whole value of the product?
Yeah, I mean, I think Teresa would probably be better suited to answer that.
Sure.
Managing their the waste that they have coming in.
Sure. If Teresa, you're happy to take that one.
Sure. Yeah. It's so we reframe it in the fact that there is value in that waste. And Yuli said it better than I could, is that there's value in your closet. And for everything that we are able to responsibly recover and recycle, that is less virgin raw materials that you put back in the system. And the cost model is an interesting one, because we talk about value adding beyond just the sustainability green premium expectations, but how do you make it worthwhile? And that's the reason trying as hard as you can to make it an easy drop in for the supply chain down the line is important to pass that hurdle, because a lot of these, especially on the PET side, they're optimized to run fast, run cheap, and run hard, and so you really have to start, and I saw this in the paper and packaging industry as well, is you are going to start with the brands. And again, I've made this comment, but you start with the brands and the partners who have the commitment, and you don't want to create something that's always going to be a niche, That's never going to go, because you don't change the world with something this scale, with something that can't eventually reach more general population usage. And Brooke, that gets to what you're talking about with where the cost has to be. Now, part of that, and we haven't touched on this a lot, but when you look at extended producer responsibility and where some of those funds come back in, and how we might use those to help lower the hurdles for developing the sorting technologies and developing some of these things and helping bring that cost barrier, that cost burden down a little bit, so that those funds are allocated in ways that raises the whole tide.
Mm. And Lewis, for Paradise Textiles, as someone purchasing fibers, as a company purchasing them and hoping to add value to your end customer through these next gen materials, how do you deal with the green premium? How is it viewed in the business?
Yeah, it's really tricky. I mean, at this point, it's it's more of like getting very crafty from an economics perspective and trying to figure out what's needed in order to get brands to pay a little bit more for these better, lower impact fibers. An approach that we've been using is like I said, where we're looking at a new alternative, looking at where it could replace a current running fabric. And what we've done is started to go out to brands and say, look, if you switch to this better alternative, we're willing to split the cost, say, of what that upcharge would be. And part of that is just like, Paradise as a manufacturer, we also have our own commitments and KPIs. And, we want to be using more preferred fibers, and we want to be, very competitive, looking at what we use today and where we want to go, and switching to those alternatives as quickly as possible. Mm-hmm. So that's kind of one way of doing it, is looking at splitting the cost of what that premium would be, or looking at over like a 3 or 5 year duration of how that fiber is going to be more competitive from a cost perspective as the technology scales, and really trying to be in like a 3-way conversation between brand, ourselves as the manufacturer, and then an innovator like Circ or Evernew or Nanolose or any of these companies working on those new technologies, so that we're all on the same page together, engaged in the same discussion, and just trying to figure out how we can get there as quick as possible.
And does it help that you're vertically integrated from that spinning process right through to the end product? I mean, you've got room to move in there, haven't you?
Yeah, 100%. I can say, for example, being on the brand side in the past, you'd engage with a company like Circ and you'd say, oh, this is awesome. We've evaluated it. We've tested it in our lab. Now, which supply chain partner are we going to take it to?
Yeah.
And then it's like, maybe you're taking it to someone and then you're like, oh, actually they only knit fabric. They don't spin yarn. And so, with Paradise and where I sit today, it's great because all of the resources are there. And, we can take it from as early as stage possible, even on, say, like the biosynthetic side, we're exploring monomers and we're running polymerization trials. And, so we're able to catch it as early on as possible. Mm-hmm. And also it helps from a cost perspective because, there's one less company involved. If, say, it's just like a knitting mill and then you have a spinning partner, we're able to come in and look at all the costs together and say, what's it going to cost to go from fiber to garment? And, there's quite an advantage from a cost perspective when you're trying to implement a more premium material.
Yeah, absolutely. One of the things that we touched on a little earlier, Charline, was the high performance element of next gen materials. And I wonder whether or not you could give any additional information as to how the testing process is done at the Microfibre Consortium and how you evaluate performance in terms of the yarn or the fibre, and how it operates in a textile and at end of life versus incumbents for next gen materials.
So currently the testing that is being done by we are not doing the testing, our signatories and our community is testing. Mm-hmm. The way we are set up is that a test method has been developed that our community is using. And then, as Lewis mentioned earlier, the results are shared so that we have a large amount of data to be able to do research based on real life data from our community, both brands and retailers, as well as manufacturers, share the results. It's obviously anonymized, so we don't share the result as such, but we are able to use the data from the whole community rather than the data that comes from one signatory or one organization. And from a research standpoint, and in terms of building knowledge for the industry, this has a lot of value because the results are less dependent on the specific of one facility that may be more advanced than another.
Got it. And so there's a standardized methodology and data collection approach there, so that it's an apples situation.
Absolutely. And currently the test is looking at laundry, so simulated laundry, but it's to understand the fragmentation of the product. It doesn't mean we only care about laundry. It's just a standardized approach. We are now developing one with ZDHC on measuring it at wastewater, as Louis was mentioned, so that we have a common way of measuring. And once we start all measuring in the same way, we can start understanding and then developing the mitigation actions. Now, what's really important for next gen materials is that to test. This what Louis, or new fabrics or fabrics in general. We just need as an industry to test, because we need the data. Only with the data we can do the research, and only the research will be able to give us indication as to what the driving factors are, and what can we do about it.
And you mentioned mitigation and guiding stakeholders as to what the best mitigation approaches might be. Have you landed on anything that you can share with us, or have you got any sort of overarching learnings so far that you could share with the audience?
Well, the first learning is that all fabrics and all fibers shed. So it's not about using this fiber or that fiber. We can see that a woven fabric, which is more tight in construction, it's mechanical, tends to shed less than a weft knit material. So the data is giving us indication, and we needed a large amount of data to be able to make this recommendation. We've just run a big research on polyester versus recycled polyester. There was a lot of debate in the industry as use of recycled polyester has been scaled over the last years. Does it have an impact on fragmentation? Do we create, as Teresa said earlier, some unintended consequences by just reusing a material rather than using a virgin fiber? And we will launch the report next week, but it doesn't appear to be the main factor. So we had almost 300 fabrics tested, and looking at our research team did the analysis, and using recycled or virgin seemed to be shedding in the same way. It doesn't mean we don't have an issue. It means it doesn't make it worse. So as we build data, we will be able to conduct more of this research to drive the understanding and the knowledge for the industry.
And I guess really it depends also on the other variables, like, for example, the structure, the textile structure, as you mentioned. Perhaps using a shortened mechanically recycled fiber is okay if it's in a certain type of woven structure that's tight. So I think I can see how that's useful.
It's the preconception was that it's a fiber issue. We should use this fiber over that fiber, but it's textile. I mean, it's so simple, but it's, Louis knows it better, or Teresa, so complex to get to to a finished product. There's so many steps, and all those steps have an influence. The fiber, the size of the fiber, is it filament, is it staple, how is it knitted or woven, how is it finished, is it washed, like a pair of jeans, where when you increase abrasion, you increase risks of fiber fragmentation. But we're at the beginning of understanding this, and it does require a large amount of data to be able to drive statistically relevant conclusions, so that they mean something.
Please, Yuli, I think you were going to jump in.
Yeah, no, I think, I mean, I'm excited about that result, Charline. I think it's a good statement of the data, and the research strongly believe on that. We need to show people what it is. But I think it also brings an interesting point about the diversity of fibers that has to exist in the market. I think one of the things I always hear is about kind of cotton versus polyester or the nylons, right? So the reason why we have that diversity of fibers is because we also kind of designing in a diverse type of products, right? And kind of finding that fitting, something that we don't really take in account is the use of that fiber, right? So for sure, for a century now, we've been building woven versus knitting because of a function of a product, right? So understanding kind of this intersection, which it hasn't been done, is something I asked some of the professors in MIT, of end of life and use, and that intersection, and really understand where do we put these precious materials back in the system, will also allow us to start thinking in the next cycles, right? And that circularity, to build a model, has to have many cycles, so then you can promise people who is putting money out there that you're going to have transactions that are going to build this economy. But if we say today, like, ban polyester and we're all going to go into biomass fibers, that's a completely unbalanced equation, both for the economy, for the planet, and for what happens into the development of textiles of the future.
What Charline has helpfully reminded us of is actually that there are so many variables at play here, and that it's an oversimplification to assume that the fiber is the dominant determiner. And we've talked a little bit about chemistry, and we've talked a little bit about uses, but also I think in the context of next gen materials, remembering that we're dealing with ingredients here, a molecular palette, and that there's, chemical engineering, mechanical engineering, other applications, let's say, that can make molecules do different things. And maybe we do well to remember that we're dealing with things we can shape and mold and make perform in certain ways, rather than sort of drawing lines along this sort of polymer type or protein type. That be fair? Would you say maybe we should try and keep that top of mind?
Yeah, I think it's not about what is. I like your analogy of ingredients, Brooke, because we still need to keep the diversity of food in the ingredients. We also need to keep this diversity in the textiles in a way that I do remember, Charline, you will remember this back in 2017 when we did the fragmentation of cotton versus polyester. The natural way of cotton is fragmentation, right? That's what the planet does. And these misconceptions help us being out there and kind of giving clarity on those misconceptions is so important, because decisions are being made on these misconceptions. So the ingredients have to stay diverse, in my opinion.
Yeah.
But just to add on that, I think it's important that we think about why we use a certain ingredient and what for, because we tend to just use everything and anything without the real performance, value, reason. And I think going back to the value of the raw material and building it into a valuable textile could help switch.
And that just comes back full circle, I think, to Brooke's question on cost and business models, because one of the things that attracted me to Circ was the fact that it was a market pulled solution. The technology is very very interesting, and there's so much great science there. But if you look at the business case, it really is trying to accept the fact that 60% of textile waste is mixed, and it's not a single source. And so you also have, 100% cotton is great until you try to run in it. And then there's a reason we blend poly and cotton. And so the fact that the technology allows that behavior and design choice to continue is that you are going to continue, and in this case, lyocell instead, but you're still going to assume some level of blending of those two materials that can then continue to come back, was one of the things that attracted me to the value proposition, because it doesn't change the wholesale. That was one of the problems in packaging that we'd seen, is if you start trying to change consumer behavior and how hard that hurdle can be. And the same thing here is, trying to make and we've talked a lot about how to shorten the leap to commercialization and success. And I think that's one of them, is keeping, Yuli, you and Charline both gave examples, but, keeping that front of mind and allowing it to continue to be a design choice.
And Lewis, you do a lot of work with brands and present products and solutions to brands. How does this work on the sort of brand front and communicating performance versus material inputs, and balancing expectations or perceptions versus the realities?
Yeah, I mean, I think a lot of it is really about testing. You're taking the material, you're running it through performance or durability testing. That way you're able to show, objective data supporting that it is a viable alternative that's not, it's going to hit your performance. I mean, a brand is going to have all these performance requirements as a part of the process, assigned spec anyway before they adopt it. Mm-hmm. So you just need to make sure you do that, and then make the right tweaks so that you can make, if tweaks are needed, you're able to do what's needed to hit those specs.
Mm-hmm. I don't know if we have time to carry on, Nicole. Thanks for rejoining us. Should we do a little wrap up, or how are we doing for time?
About 3 minutes left. So I just wanted to come on and help wrap up and say, like, every single panel, I feel like I'm learning more, and to hear from, experts who are deep in this and are really thoughtful about all the stages of the process. And again, this isn't simple. Right. And to have innovators like yourselves really thinking this through and willingness to share your learnings and perspectives with the industry is extremely valuable. Yeah. Any closing thoughts, Brooke?
I can't believe it's been an hour is my primary thought right now. And then I have many others after that, but they're all off the back of what the panelists have said. So I think I'd rather let them give another 30 seconds or so, perhaps, to just weigh in on any last thoughts on the potential of next gen materials and circularity.
Yeah, I would just say it's real important from my perspective, when you're looking at next gen materials, to consider the recyclability, and we struggle right now to make a recycling stream for PET. And if we start looking at all of these other polymers that, they are recyclable, but what's it going to take to build up that infrastructure and the stream and everything? I think that's really important to consider. Mm-hmm. And if I was just speaking for myself, I mean, I'm most excited about the future of man-made cellulosic filaments, and looking at the high tenacity version and how that could actually be a very viable alternative to replace some of that need for synthetics, as like a consumer feels it and they like that synthetic-y feel. I'm very excited about where high tenacity man-made cellulosic filament will be in the future.
I hear you on that one, and I think we bonded over that at ITMA. So yeah, totally. Yuli.
I'm excited because we are rebuilding an industry with technologies of 2023. That's how we are reimagining this. And when I think the work Nicole and the Material Innovation Initiative is doing is to give the driver of this is possible and it will have an economical model if we do it right. So understanding this value proposition to the brands, to the consumer, I think we don't have to forget the consumer in this equation, because that ultimately is us who has the power in our closet. And understanding what is going to be our evolution as a human species. I mean, today we're developing waterproof technologies. We will need to develop heat-proof technology. So these kind of things are evolving in a way faster than we can imagine. But I'm really optimistic that with the circular economy, we can build a model that enhances the possibility for the Circs and others to evolve and be part of this economy.
Charline.
Oh, you're in mute, Charline.
Yes.
I'm also optimistic if I see where we were 5 years ago and where we are today with all these next-gen materials that were in the lab that are now commercializing and becoming actually real with supply chains developing. I think what will happen in the next 5 years with the funding, the understanding, it's gonna be great. It will require a lot. It won't be easy, but I think we are on the right path. And I would say, to Louis' point, test, just to make sure it's understood holistically before we all drive it big times.
And Teresa, close us out with your last.
Yeah, we're trying to solve a huge problem at an industry level, and it is so encouraging, however, that there are so many passionate partners who will bond together collaboratively to try to do that in a way that's sustainable and lasting and impactful.
Thank you. It's been a great panel. We're out of time, but thank you to everyone. It's been fabulous, and we'll continue talking and probably see you all next year, quite frankly.
Yes, thank you all so much. I really appreciate it. And actually, I'm going to piggyback a little bit on what Charline said. And I was actually at a biomaterials conference in Israel last week with, I think, almost everyone in the audience was scientists at academic institutions or running R&D facilities. And the amount of technology and innovation that is still behind the scenes, right, and is not near commercialization yet, but is in development, is huge. And I don't think the industry realizes that, right? Because they're not going to those scientific technological conferences. So I hope we're really bridging that gap to help bring in some of these ideas, some of that insight into the industry. So thank you all so much. So right now we're going to go over to our lunch break. So we have about 45 minutes for lunch, and then we'll be back here in 45 minutes, whatever your time zone is, to hear more about synthetics. And I think that's another issue that everyone really cares about. Obviously, we have to deal with end of life, but then especially, in beginning of life synthetics, everyone's concerned about petrochemicals, and it's run by Dr. Sydney Gladman, our Chief Scientific Officer. So have a wonderful lunch, everyone, and hopefully I'll see you back in 45 minutes.
Thank you.
Thank you so much.
Thank you.
Thanks.